Hello students. As we continue on our discussion of colligative properties of solutions in this chapter, I'd like to take a quick moment just to talk about some of the other concentration units for solutions, the ways that we can report the concentration of a solution. We've talked about a few already. We've used molality quite a bit in this course, capital M and molality. And we know that that's represented as moles of solute per liters of solution. We've also discussed molality, which is symbolized with a lowercase m, molality. Similar to molarity in the way it's spelled, only one letter difference. But molality is the moles of solute divided by the kilograms of the solvent. So a very different denominator than molarity. And we've also seen, for example, in our lab experiments where we have dealt with a mass per volume unit. For example, when we were working with the copper solutions, we used solutions that had milligrams of copper ion per, I believe it was liters of solution. And basically any sort of mass per volume unit would suffice. It would serve as a valid way to represent the concentration of a solution. So you could do milligrams per liter, you could do grams per liter, you could do grams per kiloliter, you could do grams per some other unit, volume unit. Those are all valid concentration units. And I want to make sure that we are familiar with a couple of others here. One is the percent by mass. Now the percent mass, or mass percent, is one that we've seen before when we were working with chemical formulas. And you were asked to calculate the mass percent of, for example, some element in that formula. For example, what was the mass percent of calcium in calcium phosphate? And you can use that same method to report the concentration of a solution. You're just dealing with the mass of the solute. That is the part. Remember, for percentages, it's always part over the whole times 100. So the mass of the solute divided by the mass of the solution. Mass of the whole solution. And then since it's a percent, we always multiply by 100, right? And that gives us a mass percent. So for example, and I'm not going to write it out, but I'll give you an example. If you were asked to calculate the percent mass or mass percent of HCl dissolved in a hydrochloric acid solution, then you would determine the mass of just the HCl and put that as the solute in the numerator, and then determine the mass for the whole solution and put that in the denominator and then multiply by 100, and you would get the mass percent of the HCl in the hydrochloric acid solution. So I just wanted to point out that this mass percent, which we've seen before, you can also apply it to solutions. Now there's another one that you may have seen already. It's used, for example, in talking about pollutants or water quality, and that's parts per billion and closely related parts per million and parts per thousand. These ways of reporting concentration of the parts per some number, well, we're already very familiar with this, even though we haven't seen it in this form, because parts per is basically what percent is. Per centum. Cent means, or centum comes from the Latin meaning 100, right? So when we're talking about a percent of something, we're calculating the parts per 100. Well, you can also calculate a parts per thousand, parts per million, parts per billion, and it's useful to use these other units with the larger parts per number when you deal with concentrations that are very small, relatively speaking. So as an example, what is your city's approved maximum amount of lead contaminant in your drinking water. That's such a small number that you would want to measure it in parts per million or parts per billion, because those units would be more useful. So we're going to use the exact same basic format for percentage as for parts per million, parts per billion, parts per thousand. We abbreviate parts per million, parts per billion just by their initials. So parts per billion is ppb, parts per million would be ppm, parts per thousand, ppt, which, be careful, because ppt is also an abbreviation that is sometimes used for precipitate. But ppb is the abbreviation for parts per billion. So it would be the mass of the part divided by the mass of the whole solution times whatever number this is. If it's a parts per million, you'd write a million. If it's a parts per billion in this case, times a billion. There we go. You can see part over whole times the number. So again, exactly the same format as calculating a percent, only instead of the part over the whole times 100, it's the part over the whole times whatever number that you're using there. So whenever you do these problems, there's one thing that you absolutely have to keep in mind, and that is the unit, for a percentage mass, the unit of mass that is used in the numerator and denominator must be the same unit. That way the units will cancel. You can't have a milligrams mass in the numerator and a kilograms mass in the denominator. Same thing with parts per million and parts per billion. You need if you're using mass, you need the mass units to be the same. So for example, if you're told you have 15 milligrams of lead in 1 kilogram of solution, then before you can start to plug these values into our equation, you have to convert one of these mass units so that it's identical to the other. So in this case, 15 milligrams of lead could go in the numerator, and then you would have to convert 1 kilogram of solution to milligrams, for example, which would be 1,000,000 milligrams, because there are 1,000,000 milligrams in a kilogram. And then you could multiply it by 1 billion, and the result would give you the parts per billion of lead in that solution. Okay? So just keep in mind, if you're using mass in your numerator and denominator, the units of mass must be the same so that they can cancel. Okay? So I just wanted to go over a few examples. There are many other concentration units that you could use. If you go on and study chemistry further, like in analytical chemistry, you might encounter one that's called, strangely enough, normality. So you can have molarity, molality, and normality. And I always thought that was kind of funny that those words sounded so much alike, but they mean slightly different things. So you could have a 3.5 molar solution, or a 3.5 molal solution, or, and I always thought this was kind of funny, a 3.5 normal solution, right? So there are lots of different ways that you can report concentrations. And I just want to make sure that particularly these two methods you were familiar with. Okay? That's all. Have a great day.